In this video, I'm going to show you how to wire a PNP sensor to PLC device. I'll be using a laser distance sensor from Wenglor. It is a digital PNP normally open sensor. I'm going to show you how to wire a PNP sensor to two PLC devices, Bradley Micro820 PLC and Arduino Opta PLC. I'll give you some introduction first of syncing and sourcing, but you can skip to the wiring if you prefer. In general, in order to connect sensors to PLCs, there are two common main circuits. One for digital sensors, including syncing and sourcing, and one for analog sensors, including 4 to 20 milliamps current loop circuit. There are other methods depending on the sensor type, like hard communication, Profibus, etc. For digital inputs and outputs, it is important to understand syncing and sourcing concepts. When working with PLC I/O modules, sourcing PNP module is when current flows out of the PLC port, it acts as a source. Syncing NPN module, the one you see on the right-hand side, is when current flows into the PLC port, it acts as a sink. The devices that are connected to the PLC I/O modules are also labeled sourcing and syncing. When we have a sourcing module, the device connected to it is a syncing device. In syncing devices, the current flows into the device from the module. The module or PLC provide or source the current, and hence the name. A syncing device is always attached to a sourcing I/O module. The same thing for a syncing I/O module. The device connected to it is a sourcing device. In sourcing devices, the current flows out of the device into the I/O module. The module or the PLC receives or syncs the current. A sourcing device is always attached to a syncing I/O module. So simply like a puzzle, you have two options: sourcing that is connected to a syncing, and vice versa. You cannot have two sourcing or two syncing parts. The terms sourcing and syncing, or PNP and NPN, are both used in industrial settings when working with PLCs or sensors. However, for simplicity, we refer to PLC I/O modules as syncing and sourcing, and sensors as NPN and PNP sensors. However, both terminologies are correct, and you can see them often in documentations. Sourcing and syncing circuits consist of the following: sourcing part, syncing part, and a power supply. In general, these circuit diagrams look like this, showing how current flows through sourcing and syncing I/O modules when a device is connected to them. Sourcing I/O devices or I/O modules will always have connection to the positive side of the DC power supply. Syncing I/O devices or syncing I/O modules will always have connection to the negative side of the power supply. Some PLC's input modules can be syncing or sourcing, depending on the wiring diagram. You can wire PNP or NPN sensors to them. In this video, I'll focus on the circuit for a PNP device and a syncing PLC input. For this circuit diagram, the module is a syncing input module. The sensor is a sourcing PNP device. Notice also the positive side of the power supply is connected to the sourcing device. Now for the wiring, I'll be using a laser distance sensor from Wenglor. It is a digital sensor and the output is PNP normally open. And here you can see the wiring diagram for this PNP normally open sensor, and it has 4 wires. For the first part, I'm going to show you how to wire a PNP sensor to Bradley Micro820 PLC. For any 4-wire PNP sensor, the colors go this way. Brown and blue are power wires, black and white are signal wires. So if the sensor output is normally open, then we use the black wire. If the sensor, the PNP sensor, is normally closed, then we use the white wire. Since this sensor is a PNP normally open, then we are going to use the black wire for the signal. For Bradley Micro820 PLC, it has syncing input ports from input 0 to input 11. Notice here the wiring diagram for PNP sensors. So the wiring goes this way. The brown wire from the sensor goes to the 24, the positive side of the power supply. The blue wire goes to the 0 volt of the PLC. It's showing here -24. The black wire is the input signal, and it's connected to the input port, which is input 1. And the white wire isn't connected to anything. And in order to complete the syncing wiring diagram, we need to connect the negative side from the power supply, the -24, to the negative DC, the -24 of the input module of the PLC. And here you can see a demo of how I do the wiring. Now, in order to power the Bradley Micro820 PLC, I am going to connect the power supply to the PLC. And the power supply is connected to the power outlet or the electrical outlet. And of course, there are different outlets and plug adapters. So please note that you need to be mindful of the electricity standards of your country. The second part of the wiring is I'm going to show you how to wire a PNP sensor to Arduino Opta PLC. As you can see here in the data sheet, here are the details for the digital inputs of this Arduino Opta PLC. As you can see, it can accept both NPN and PNP sensor depending on the wiring, as long as we are mindful of the input voltage requirements, which is 24 volts. Again, the same thing applies for any 4-wire PNP sensor. Brown and blue are power wires, black and white are signal wires, and for normal open we use black wire, and for normally closed we use the white wire. And since this is a PNP normally open, then I'm going to use the black wire for the signal. So the wiring goes this way. The brown wire goes to the 24 voltage power supply pin. The blue wire goes to the negative side of the power supply pin. The black wire is the input signal, and it's connected to input 4. You can choose any of the inputs. I chose input number 4. And then the white wire isn't connected to anything. And here is a demo of how I do the wiring for PNP sensor with Opta PLC. And for this PLC, the Opta PLC, we need to connect to the power. We need to power the device. And I'm going to connect the power to the pins over here. I hope this short demo helps in showing you how to wire PNP normally open digital sensor to PLCs. I will leave all the resources and the references in the description box below this video. And I also have courses on LinkedIn Learning about this if you like to learn more. One of the courses covers the syncing and sourcing concept, and the other one covers the 4 to 20 milliamps current loop. Again, I will leave the link to the two courses in the description box below this video. Thanks for watching, and I will see you next time.